Yes, thank you. Hopefully you can see our title screen right now.
Looks good.
Great. All right. So yes, my name is Elias, and together with Emma and Yin, we have created a visual storytelling concept for climate communication in the decision arena called Seasons of Climate Change. Yes. So our inspiration of the project came from the recently released assessment report from IPCC, which Cornelia briefly mentioned before the break. So that was great context. And especially we have focused on the summary for policymakers. So that is a version that they created for policymakers. And this summary presents the understanding of the current state of the climate and how it is predicted to change in the future. But it does this at a fairly global scale, however, which can make it hard to relate to the data. So our idea was therefore to make the data more relatable through visual storytelling in order to increase the public interest and insights of the facts that were stated in the IPCC report. We partly based our work on the figures included in the summary, which you can see some examples here. And especially the examples we've chosen were those of spatial and temporal data, such as time-lapse and maps, since they are inherently easier to relate to. And to make the information more relatable, we narrowed the scope of the data also. So spatial information was narrowed from global levels to regional, meaning our own Swedish region here of Östergötland, actually. And instead of conveying how climate change changes during 100 years, we instead want to focus on how 1 year in the beginning of our century compares to one at the end of it. And the second aspect of our project was to utilize the decision arena. And this is a facility here on campus Norrköping where up to 10 people can be seated in a rounded table. And the main purpose of the arena, as the name implies, is to serve as a support in decision-making where complex issues are to be discussed, which in the context of this arena often is climate-related. So a cylindrical display surrounds the participants where everyone can share their visuals through input boxes on the table. And then display is then typically used as this picture shows, where a person can share what's on their screen, basically. And it's also possible then to rotate these windows to customize how you want things to be structured. So our idea with the decision arena was to not use the display to share individual screens, but instead to show a continuous visualization across the entire display. This we think would create an immersive and innovative way of conveying information and give insight. And in regards to our chosen data, the cylindrical screen would also create an intuitive way of displaying annual cycles, as you can see with one of our first concept images here, where basically the mounts would wrap around themselves and then creating a circle of a year, basically. And presenting climate data in this way, we think would also evoke more emotion and make it feel more relatable, since the visualization basically surrounds the participant. And because of the rounded table, the environment would also encourage a more social experience compared to other environments such as a dome theater, when it's more of a passive spectator. Because here then participants would be able to discuss findings that were just presented on this display. So by combining the aspects of making the IPCC summary more relatable and utilizing the decision arena, we then come up with this visual storytelling concept called Seasons of Climate Change. So the concept is in the form of a presentation in the decision arena where a presenter goes through two timelines comparing the year of 2000 and 2100 in Östergötland, which are then augmented with animation and images, as you see here in our first concept picture of that. And the focus is then made on the 4 seasons of the year, which would divide the cylindrical display around them into 4 seamless parts. And we will now show a short demo of the video where we kind of went through ourselves how our presentation of the seasons would look like in the decision arena, which is presented by Emma in the video. And Emma afterwards will then also talk more about the key parts of our concept. But now we can look at the video, which is about 3 minutes long.
A year in Sweden, Östergötland. So we decided to look at what a year in the future, specifically 2100, would look like under RCP 8.5. And what will happen is that we will have more precipitation, but this precipitation will come down as rain instead of snow, as it did before in the year of 2000. This would also lead to a decrease in frost days since the temperature has increased. Going into spring, we will actually experience less spring flooding in the future than we are currently doing. And this is because the increase in precipitation in the winter, which is rain precipitation and not snow precipitation, will already lead to flooding then. So we've kind of had our flooding already, compared to now when the flooding is usually in the spring. And having the flooding in the winter might lead us to have to do quite big infrastructural changes in traffic and buildings, since the water increase in city close landscapes might be too much for our current infrastructure to handle. We can also see that different parts of Östergötland will be differently affected by the flooding. And we have already experienced flooding in Östergötland. For example, you can see here a picture of a flooding in Ödeshög in 2007. And also on the left, you have some plans for where there might occur a lot of flooding in the future in Linköping municipality. Well, another interesting thing is also that the growing season will start earlier in the future. The growing season is when you can grow crops. So in the future, it will start a lot earlier, since the temperature is much higher earlier in the year compared to now, when it starts a bit later. And the growing season will continue into summer. But that's when some interesting things start to happen. Since we have this temperature increase, we will have less precipitation in summer than we have right now. And we will also have a lot higher temperature, which will lead to heat waves. And these heat waves might actually cut our growing season short, and then our crops will die, and we won't really benefit from this longer growing season some years. Compared to now, where we probably have a lot less droughts, so we have a complete growing season more often than we will in the future. Going forward through the year, we come to autumn, and that's when the shorter growing season right now stops earlier, and in the future our growing season might already have ended, or it continues forward a lot longer and we can have more crops. And this is what a year in Östergötland would look like in the future. Thank you.
Okay, so as we saw in the demo video, we did a selective detailing of our seasonal timeline for our concept. But our concept consists of more than that. We have an introduction, and we then introduce climate scenarios a bit, like Cornelia talked before, so that people are aware of what these different scenarios are. We then go from a kind of global context to the local context, which is the seasonal timeline. And then finally, we have an outro. And what I wanted to start with talking a bit more about is how we try to introduce our audience to this concept. So we start quite simple by introducing the current context of climate change. So we use some pictures that we think represent global warming and climate discussion currently, and then we establish that in the current climate researcher community, climate change is established and it will have consequences for humanity at large. And then we start by looking at the global context for climate change. And here we look at the global average temperature between year 1 and year 2100. And we have this timeline of the global average temperature and its variation. And for the majority of this timeline, like the first 1700 years, the temperature is very similar, and so is the variation. But then when you get to the end, you can see the observed temperature increasing. And then finally, you have these climate scenarios, which depict different possible futures where how much humanity acts on climate change will basically decide how things go. And what we think works here is that you're surrounded by this data that is very much the same. And this is in a very like sheer scale, big, large scale. And then you get to the end where you have a very quick change. Another benefit of using the cylindrical display is that you can compare the past with the future. So here we have the past on the right, and then you can see it's very much the same. And then you have on the left, you have the future, where you have these scenarios. And then you can really also appreciate how big of a difference there will be in the future compared to the past. And we also wanted to see that being surrounded by this data on the cylindrical display allows you to see how other people react to the data presented, which gives a bit more of a social context during the presentation itself. At the end of our introduction, we show 4 different maps where we show how the increasing of the global average temperature will vary across Earth. And then we go from this and zoom down on the local context, which is the seasonal timeline. And for the seasonal timeline, we use the display to really show changes between years. Because since the display is so big, you can show 2 years at the same time. So we have the future year and the past year. And you can easily compare between the seasons here. As you can see with this winter, we compare the number of frost days, the type of precipitation, and so on. But it's also easy to show change across seasons while being able to augment these timelines. So since the display is so big, we can put icons, animations, and so on. And we can also show pictures while still keeping the graph and not having to switch between these images. And we also have this walking man here that we use to sort of transport you along the timeline. This is to make you feel like you're walking along the seasons. We also use a lot of icons and images, as you see. And one specific one is the house. And the house represents the home. And the home is, of course, very personal and relatable to most of us, right? And we wanted to use the home to make our audience think about how climate change will impact them. And one specific sort of variable or data that we looked at was the number of degree days. And degree days is a way to measure how much energy you will need to heat or to cool your house, or how much is required, basically. And as you can see, for the number of degree days for heating will decrease as the temperature increases, but the number of degree days for cooling will increase instead. And if you only look at the left graph, you might think this is a very positive thing, because the energy costs are very high, at least in Sweden currently. And needing to heat your house less will have a positive economical impact for people. But if you then look at the other graph, where you actually might need to cool your house a lot more, it's not very positive in a Swedish context, because most people do not have air conditioners. And a lot of public buildings do not really have infrastructure for cooling as much as is needed currently either. So then we will need a lot of infrastructure investments. This is just an example of how we try to apply this data to our icons and how we could augment this seasonal timeline in different ways to present current climate data. We also use an outro, and here we present our data, where we've gotten our data from. So SMHI, which is like the Meteorological Institute here in Sweden. And then of course, IPCC data. And this is just to show that our data sources are credible and, you know, recognized, to yield our presentation a bit more of credibility as well. And we also then tie back to the global context. And this is, here we have an idea of trying to tie what we have presented to the Global Sustainable Development Goals presented by the UN. And this is also a way to kind of make people think and make people talk about how they think climate data might affect our, or climate change might affect our possibility to reach these goals, and how our data shown ties into these goals. So that's the main parts of the concept. And our audience is an audience that we believe have a general high school knowledge of climate change. And the presentation can be done for study groups, business groups, maybe even local decision makers. And one part of our presentation that has been important to think about is the ergonomics of the decision arena. Since you sit around this circular table, and each person has a rotating chair that they can just rotate around, you don't really need to strain your neck super much to watch our presentation. However, you still strain your neck a bit, so we needed to keep our presentation rather short so that people do not feel like they need to strain their necks too much. But it's still possible to follow along quite easily by rotating your chair. We also thought a lot about how to immerse our audience. One way, of course, is the social aspect, that people sit and see how other people react. So it's a social experience, but also that we have this cylindrical screen, or, you know, kind of in the data surrounds you. Finally, we also have in our concept the idea of pausing the presentation and asking questions to create discussions. So for example, we might pause and then show and talk about, after we have talked about degree days, for example, and then we might ask, okay, but how do you think this will affect your daily life? What would the economical impact be for you? What would the social impact be for you? Maybe you hate snow and you'd love to have no snow so you can be outside more in the winter, or maybe you're the opposite and feel like not skiing would be horrible. Basically trying to make the audience think about how their lives will be affected by these things and try to apply it. And we think this will lead to a sort of cognitive immersion where people really start to think about the data and might keep it in mind for the future when they leave our presentation and room. Finally, we want to thank our collaborators. Sophie helped us think about how to communicate climate change in a way that people can relate and understand, going from this global to narrowing down to the local context. We also want to thank CSPR, Lotten, Tina, Carlo, and Emma for their help with creating a manuscript from our concept that sticks to current climate data and research, for helping us understand different climate data variables that we did not understand very well, and for helping us pick like the climate indicators that are important. So we chose temperature and precipitation, and these are both have a high impact, right? But they are also easy to understand and visualize and apply to our regional context here in Östergötland. And yes, now I will leave it to Yin to explain our design process throughout this project that we think will be of benefit to you. Thank you.
Hey, this is Yin. I come from the immersive group as a designer here. I think there's two things we can move forward with the project we was working on. One is I call it the creative DNA. I think with this project, we find a really good way to coordinate between researchers and designers. Basically, with this process, we would say it's quite easy for us to work with any researchers in the team want to turn their data into storytelling with following this process, which is if you see, follow the blue line is what the researcher did, and the green line is what the designer did. Sometimes we work together, sometimes we work separate on what we are good at. At the beginning, it's basically the researchers decide the topic and what media to do the storytelling. Then we discuss the scope of the story, then we separate. It was Emma, Elias collect the data and explore the focus of story, while I'm exploring the visualization method. In this case, it's Watchout, because Watchout is a software to work with this multi-displays. And then it was researchers developed the draft storyboard, and I was collecting the visualization elements as like this house, these trace things. Then its developers created the data visualization draft, and I converted it into a PPT storyboard. Then we start to review and streamline the story tested in Decision Arena. I think that is really good core design process together. Then we have this PPT you see in the video. We will be able to discuss and present this story with all the stakeholders in the pedagogy team in visualization center. And with this input, we will be able to have really detailed discussion on how we can convert into a series of exploration workshops for the public. So the next step, I will spend time to make Watchout version of what we discussed here. Then we have discussion and we will try to convert into something we really can benefit the public. Yeah, that's all from my part. Anything you want to add, Emma and Elias?
No, I think we just want to say thank you for listening to our presentation today.
Thank you so much, Elias, Emma, and Yin, for a wonderful presentation and a wonderful piece of work, and almost sticking to the allocated time, which is wonderful because we have time for a couple of questions. There was a bit of a discussion in the chat concerning the actual physical properties of the decision arena, which is very, very peculiar from an audience presentation point of view. There is this round conference table in the middle, and there is a cylindrical display going all the way around. And you have a concept that is based on one point of interest along these 360 degrees and kind of following it around. And some questions in the chat concerned the possible discomfort of the audience when the presenter moves during her presentation around essentially the whole room and around the whole table. You did touch upon it by mentioning the swiveling chairs and the next train and so on, but I was wondering if you have any more thoughts on how you could use the physical peculiarities of the decision arena in other ways, if you think about perhaps extending your concept towards workshops or something like that.
Yeah, but yeah, it's really been our most practical issue, and for our concept, it is mostly linear, that you follow a point. But I could imagine you could have two different modes. You could maybe have like a non-linear mode where instead of following a presentation, everyone explores the data around the cylindrical display, and then maybe you discuss and talk about your findings. So I could imagine there can be better ways of embracing the ergonomics in that way. But yeah.
It's also possible to be solved by Watchout production. Then we can just rotate the display so people don't have to move, just the story moves.
Yeah, yeah. But in that case, you would rather have a horseshoe table than a round table, I would say.
Yeah.
So it's kind of tricky, this, because the decision arena is potentially so exciting, but it turns out to be super difficult to do something useful in. But I think you have really given it serious effort. I think that's the best anyone can do. And this clearly seems promising to me anyway. There's another question in the chat before I give the word to Cornelia. It's a question about how much research you had to do to go from the IPCC report to this very clear presentation that you had in your timeline. Was it all there, or did you have to do a lot of your own calculations and things?
I think like going from the IPCC report to the local context, me, Elias and Yin, we reached out to our collaborators basically, and they helped us do that. And we also used data from SMHI and the IPCC then, and we did some for the SMHI data. I think we did some. I have like an Excel sheet where I've done some averages and things. And getting the IPCC data into usable graphs was also a bit of work, but not super much. It was just recreating the graphs. Basically, the data is quite clear. You get the average, and then you get these confidence interval, like the 95 and 5%, and then you just need to create the graph. So it wasn't much calculation, I wouldn't say.
Great.
Yeah, but we really had a turning point in the project where we had all this content and data, and we thought like, oh, we could create these scientifically accurate graphs in the decision arena and so on. But then we remember the course and the deadline, and that we should focus on the design. But yeah, there's lots of future work that can be done in that area as well.
Sorry to keep giving you these frustrating deadlines. And
yeah.
I know it would be much better if you could just do whatever you wanted. Anyway, thank you. There is one more question. Has to do with what you talked about, Yin, the workflow and the way designers and researchers coordinated in this project. The question is, can you mention some lessons learned from the process in terms of the methodology or the workflow?
On my side, I think all the lessons learned is rather positive lessons learned. I find it's quite easy if everybody do their own job. So in our project, it's quite easy. I just get a story draft brainstorming idea from Emma and get the data from Emma, and Elias help us align everything, set up the temperature template. So I think lessons learned, if everybody do their own job, even 3 people team can make a big project.
Yeah, assuming you have clear coordination points and clear deliverables like you suggest.
Yeah, and I think we didn't really spend much time on it. We only have 1 hour weekly meeting to talk things together, and everybody separate do their thing. Personally, I didn't invest too much time in it. It just works.
Lovely.
The lessons learned is it works if a researcher and designer all do their own job quick.
That's great. That's for you, Peter Westerdahl, to take note of. Just wanted to throw the question to Elias and Emma also, of course. Do you share Yin's impression that it works if everyone do what they should?
Yeah, it's all about having the right hopes about the project, because we encountered some technical difficulties, I guess you can even see in the demo, because there we used PowerPoint basically. So it's different PowerPoint slides, and you could see like there was different brightness of the displays that shouldn't have happened. And yeah, our hope in the beginning was to create a watch out project, but we understood that we needed to create more of a concept. And there we thought that PowerPoint worked great, where you can kind of simulate a cylindrical display with several inputs.
Thank you.
Yeah,
Emma, anything to add?
Yeah, I think our collaboration really worked well. I guess like the hardest part was probably for us to narrow down. I think we had really big ambitions, and to realize that we really needed to limit ourselves a bit.
Yeah, but that's not really a process problem, is it? It's more of a personality problem.
Okay.
And honestly, as a teacher, it's a fantastically good problem, because it means that you end up doing spectacular work in a fairly short period of time. So thank you all very, very much. And here is some applause for you. Just to wrap up this part, there was a comment in the chat that seemed kind of productive, which essentially said, if you could throw out the round conference table and just use more flexible chairs and perhaps handheld boards for note-taking and so on, you could make this into a more dynamic workshop environment while still using the cylindrical display. And I think that comment makes a lot of sense, of course. But I realize also in your situation that was not an option, because these tables are actually bolted to the floor in the decision arena. So it's not like you feel like you can move them around. It's a pretty peculiar place to work with. But in principle, I think the point is very valuable. You could imagine the participants being able to move a little more freely around the room while the presentation was happening in a 360-degree kind of context. So it'd be more like a cave, essentially, than a decision arena.